This is the 5th tutorial of Classification using Machine Learning and Introduction to Classifier series. In this tutorial, we will discuss the k-nearest neighbor classifier and how to program it MATLAB by using the PR tools. Okay, let's learn the k-nearest neighbor classifier. It simply works on features similarity and classifies a data point based on how its neighbors are classified. It stores all the available cases and classifies new cases based on a similarity measurement. A similarity between feature vectors can be simply determined by using distance computation formula in a multidimensional feature space. You can use Euclidean distance, Hamming distance, Manhattan distance, Minkowski distance and so on. Look at the example in the slide. Is the apple red or green? With the number of neighbors, that is k, set to 5, the model predicts the new query as a red apple. In the next slide, you will learn how to determine k. The optimum k will always vary depending on your data set. Ideally, it should be as big that noises won't affect the prediction highly, and as low that one factor doesn't dominate the other one. Choosing the right value of k is called parameter tuning. In the example, you can observe, if you select k equal to 3, then new query will come out as red apple. But, if you select k equal to 7, then new query will come out as green apple. Therefore, determining the right value of k is an important factor for better accuracy of the KNN classifier. In a moment, you will learn how to determine k for a given dataset. There are several methods to determine k. The easiest way is the square root of n, where n is the total number of features per class. You can use the Schwartz criterion that determines k by using the function shown in the slide. In the formula, d is the dimension of the problem. N is the number of features per class. Lambda is the parameter to be specified. You can also use the cross-validation methods that we discussed in the evaluation methods tutorial. Typically, the higher value of k has a lesser chance of error. However, you must select the odd value of k to avoid confusion between two classes of data. Okay, I guess it clears the k selection process. Some of the advantages of the KNN classifier are: it is suitable for multi-class classification provided the dataset is labeled. It works well for both classification and regression. KNN algorithm is very simple to understand and easy to implement. However, you must ensure that the dataset should not to be very large because KNN is a lazy learner. KNN is a non-parametric algorithm making fewer assumptions about the data. Therefore, you must ensure dataset must be noise-free, that is, there should not be any ambiguity with class labels, as well as objects features to be homogeneous. Next, we will see some of the common application of KNN classifier. KNN classifier can be used for solving classification problems related to healthcare sector in disease diagnosis or genetics, agriculture sector for climate forecasting and estimating soil water parameters, text mining for text categorization, financial problems like economic forecasting. Next, you will see how to use KNN classifier using MATLAB PR Tools. This slide shows MATLAB's PR tool method for the KNN classifier. We recommend referring to the link provided in the video to learn to program the classification model using a KNN classifier. The arguments provided to the method are: A is the dataset, k is the number of the nearest neighbors. This method returns the mapping function w, and e is the leave one out error of the method. For any questions, please write your comment. Thank you for watching the video. Please subscribe to my channel and like the video.